When it comes to high density interconnect PCBs, and especially high speed PCBs, there are various kind of vias you need to use for different purposes. All right, I will explain the different via types and show you how to implement them in Allegro X. I'm Kurj Mackey, an electrical and electronics design engineer, and I design hardware and printed circuit boards. In this video, I'll show you how to use Allegro X to set up your vias, and you'll also understand how vias play a significant role in signal integrity, high-speed digital design, and in HDI boards. All right, so jumping into Allegro X, right? We have in our setup menu, you can go into the constraints and a constraint manager. The constraint manager lets you go into this physical section and this worksheet under the net section called all layers. That's all layers of the PCB. Then you have your nets like CSI, zero clock and whatnot. These are differential pair. You want to go and scroll horizontally to this column that says vias. This is where you set the types of vias that connect the different layers of your PCB. This is a 10-layer printed circuit board, HDI. Let's click on this cell and then you'll see the different vias pop up for that net. You can pull the vias from this list on the left, and this has all kinds of pad stacks like surface mount pad stack, mounting holes, everything you can put in here. And then you can pick out your vias, put them in the via list, set the priority and say, hey, we want vias that only connect you to layers 1 and 2, layer 3 and 4, or completely through, or layer, 5 to 7 or 5 to 8. Now I'm going to go ahead and explain these. So the via provides you vertical interconnect access. Essentially, it's a trace in the Z direction. Now, normally, if you're not doing high density boards, you're going to be using a through hole via. What is that? The through hole via, which is not shown here, goes all the way from the top layer of copper on your PCB straight through to the bottom layer of copper on your PCB. So you can see the whole of the via on the top of the board and on the bottom of the board. And that type of via is actually the cheapest to manufacture because you could just do one drill hole, stack your PCBs, and you're good. However, that's not the best for signal integrity. I'll show you why. If you have a via that's going all the way from the top to the bottom, and you say have PCIe signals, which are on layer 3 for this design, and we need to keep their EMI and their signals contained to specific layers, having your signal access all layers of the PCB is going to be a problem EMI wise. That electromagnetic interference, those EMI pulses are going to just go everywhere where the via can be found. Layer 1, layer 2, layer 4, layer 6, layer 8. We don't want that. Okay. So engineers decided to come up with a method to limit where the signals can travel, and that is the blind via. So the blind via is one where you're starting at the top layer for your via, but you're stopping at just the layer you need the signal to be connected at. So say layer 1 to layer 2, or layer 1 to layer 4, and so on. That's a blind via. What's the blind part? The bottom hole of the via, we can't see. We're blind to it. But the top side, we can see. Okay. Now, the other type of via, let's say we need to go from layer 2 to layer 3, like we show here. Limiting the signal to layer 2 and layer 3, that is a buried via. It's buried in the PCB stackup. That's good for signal integrity so that your signals are not going all over the place. The only problem with this is that they are more expensive. They're way more expensive. So you need to be careful when using these. Use these only as necessary to make sure your signal works. All right, so now that you understand the purpose of your through via versus maybe your blind via or your buried via for signal integrity purposes, we need to look at tinier vias, which are microvias. These are vias that are made using lasers instead of the standard drill method for your blind, buried, and through vias. We use those microvias when the PCB is extremely dense, particularly dense, and we don't really have the space to drill holes, or the vias are too small, like 5 mil diameter or 6 mil diameter for the hole size. That's way too tiny. So you need to use lasers to etch those vias in there. Now that we understand the different via types, I'm going to show you how you can make them. So check this out. How do you even make the vias that go in this via list? So I'll show you. So we go into our design, hit cancel. I'm going to X out of here. Then go on, say my top copper layer underneath this BGA device. The vias show up here. They're like these little circles inside the pads of these ground pins. What I'm going to do is go to my tools, pad stack, modify design pad stack, and I'll select one of my vias. Let's choose this 1 to 3 via, for example. Edit this. This opens up the pad stack editor. Now I could have opened it from my Windows Start menu, whatever works for you. I'm going to open it from here. Notice how it connects only layers 1 and 2 showing up in this cross section view. And this is the whole for the via from the top view. The cross section view shows you the layers it connects to. So and this is the side view. If we choose front or side, same thing. Now let's go from start to finish how this works. You can start with a through pin via, which is good for most boards, but if you're dealing with high-speed signals, then you want to go with either a blind or buried via or a microvia. Now this type of via we're looking at is a microvia. They are slightly slanted, laser etched. We look at the drill size. The drill diameter for this thing, 0.1 millimeters, very tiny. If you want that converted, you can change it to mils. And that's only 3.94 mils. So we're talking extremely small here, extremely small hole that is laser etched. You have secondary drill that comes with back drill. That's a middle of the ground cost or solution when you can still do through vias but back drill them. Next, we have the drill symbol that you set. Next is the drill offset. We can ignore that. Now we have design layers. This is where we say we need a rectangular pad on the top layer, layer 2, and you specifically define the layers for your PCB stack up. Notice how we say no circular pads any kind on layers 3 through the bottom layer. Then we have our mask layers. There are none for our microvias, your different options, and your summary of your microvia. So that's how you can define a microvia or any via type in your PCB stack up. Just use this menu and choose the options that make sense for your application. I'm going to go ahead and exit out of that. You can save your via in the appropriate folders and Allegro will know where it is, find it, and allow you to put it in your via list. Now, is the purpose of a microvia or blind buried via, whichever via you're using, is the purpose to just manage the integrity of a signal and to manage and reduce EMI? No, it's also perfect for preserving space, which is exactly what you want in high density interconnect boards. See, the less of your vertical layer you have to use with any of your vias, the more space you have. There's a lot more space when you don't have to go all the way through the PCB. You just go from layer 1 to 2 or layer 1 to 3. And then in between the vertical areas of those layers, you can go from 2 to 3 and 2 to 4. So that's the biggest advantage when you have microvias and blind and buried vias that access only specific layers. With that being said, let me show you a demonstration of how that's applied in our design. So looking here, we have a chip on the top of this PCB, this U2701. Underneath here are balls in a ball grid array configuration. So if we go to layer 1, that's what's showing up here. This is the footprint that goes underneath the pads in the ball grid array or BGA. Now, this signal out of here, like this SPIS in, I can route and say, hey, I want to take this signal, start routing from layer number 1, form a via, right? And the via I add would be layer 1 to 2. Okay, I don't have to go all the way down to layer 10 just to make my connections. And looking at my options here, I got 2 different types of vias I could do. I could do layer 2 to layer 7, depending, but yeah, layer 1 to 2 is the best because that's the type of via that's allowed on this trace or signal. Here we've got the layer 1 to 3 via. And when I do a 3D view of this via by clicking on it, it shows up like this. This is what it looks like in the 3D view. Okay. So yeah, that's all you have to do. Just if you want to use your via, start routing, start your trace. Okay, that's a little large. 1 second. If I go from, let's say, 1 to 5, I could right click, add a via, or I could change to a specific layer. Let's say I want to go to layer 3. It won't let me go to that layer because it's not set in the constraint manager to allow me to do that. Okay. But if I just drop a via in here that's allowed by default, then layer 1 to 2 and so on and so forth. Okay. This is how you can maximize your spacing during your routing for HDI applications and also manage your signal propagation. But yeah, very common practice in HDI PCB design. All right, that's it. You've learned the primary reason why we use microvias, blind and buried vias in HDI PCB design. It's to save space because the design is so tight. It also is to manage the EMI and the signals in the PCB so that we're not spreading electromagnetic fields all over the place or run into unnecessary signal integrity and signal reflection issue. If you have a high-speed board, usually you will if it's a HDI PCB. All right, so that's all I wanted to share. You know how to add your PCB stackups, you know where they come from and the type of vias that exist and how to create them in the pad stack editor and in Allegro X. Thanks so much for watching this video. I will see you in the next one.